Our objective for this video is to be able to graph tangent and cotangent graphs. We've already looked at sine and cosine graphs, and we're going to use some of the basic information we have about sines and cosines to help us with tangent and cotangent. But it's very important to recognize at the beginning the difference between tangent and cotangent and sine and cosine. You're going to see that tangent and cotangent have a smaller period than sine and cosine, and also tangent and cotangent do not have an amplitude because they go off to infinity and down to negative infinity. So some information we've already used on graphs. For instance, we've talked about asymptotes before. An asymptote is where the graph is undefined. Now in the past, that has been oftentimes where a denominator would equal 0. We're going to use the fact that we know a tangent identity which involves a fraction to help us define those points. So our tangent identity is that tangent theta equals sine theta over cosine theta. Now, if this is what tangent equals, remember cotangent is the reciprocal of that. So cotangent would have to equal then cosine over sine. Now, we know when cosine and sine are equal to 0. We did that on our graphs before. So that's going to help us establish that for our tangent, we're going to have the asymptotes where cosine is equal to 0. Where cosine theta equals 0. That's where our asymptotes are going to be on this graph. Notice that cosine is equal to 0 at pi over 2, or the same as 90 degrees. Also at 3 pi over 2, or 270. That's going to give us our asymptotes for tangent. Cotangent, on the other hand, that our asymptotes are going to be defined by, they're going to show up where sine theta, the denominator, is going to equal 0. So notice sine is equal to 0 at 0, at pi, or 180 degrees, at 2 pi, or 360. So those values are going to be where they define the asymptotes. Now we want to make sure as we look at these graphs, you add arrows onto these because these do go on toward infinity and negative infinity. So do that on each of these because that will help remind us that the asymptote, it doesn't end there. Okay, now this is 3 periods of tangent. This is 4 periods of cotangent. Remember, a period is when it repeats, and so we see the repeating pattern. The other pattern I want you to see from these graphs is notice that tangent, a standard family of function tangent, starts down and ends up. So starts down and ends up for it, whereas cotangent starts up and ends down. So that kind of pattern will help you draw the graphs. Now let's go ahead and do our standard period for these. Notice that from negative pi over 2 to pi over 2, that's 1 pi, or from pi over 2 to 1.5 pi is going to be equal to pi. You can see it a little clearer here. From 0 to pi is pi for a single period. Also, remember we've done these in degrees. If you did this, it'd be 90 degrees, and this would be negative 90 degrees for these asymptotes, whereas this one, pi, would be at 180 degrees. So notice 180 degrees, and degrees would be our period. That's half of what the standard period was for sine or cosine. So the period for these, both of these, the period is pi or 180 degrees. Now, it's important to recognize amplitude is the measurement from the middle of the graph to the top point. It gives how much distance between those. Because these go off to infinity, there is no amplitude. Okay, no amplitude because it goes off to infinity. All right, let's talk about how we can change the period on this using these different values and how this will affect our graphs. So if we look at amplitude and period changes, since there is no amplitude, let's address that first. The number in front, the A value, all it does is stretch or shrink the graph. Now it's difficult to measure that when we're just drawing these graphs. We're not spending a lot of time. So I'm going to put here difficult to measure only because we're not being as precise as possible. And so we're not going to plot a lot of points that could give it that shape of how fast it goes up. But if you have a number, like if you had a 5 in front of that, that would make these graphs go steeper up and up quicker, whereas if you had a 1/5 in front, it would mean it would come up and it would gradually go into that turning point and then gradually come out. Okay, but again, difficult to measure in how we do these graphs. The period, on the other hand, we're going to take this b on the inside, and if it's going to be in radians, we're going to take pi divided by b for our period using this formula, or if we're dealing with degrees, it's going to be 180 degrees divided by b for that. So when we look at our standard graphs, we typically look at drawing one on a tangent graph, so we're doing tangent here. We usually look at one asymptote on the positive side and one asymptote on the negative side of the origin, because our graph goes like this, comes up, goes in gradually into the origin, and then comes out. Now these points are going to be half a period to the positive, half a period to the negative. So if I take this and I take half of it, it's going to be pi over 2b, and this will be negative pi over 2b for this negative asymptote. Or if I take this one here, I'm going to not simplify it just so that we get the idea behind it. Take 180 degrees divided by 2b, which would be 90 divided by b. And here we have negative 180 degrees divided by 2b for the negative asymptote. Half a period back, half a period forward for tangent. For cotangent, it's much easier because you have the y-axis as one of your asymptotes. So you just go one full period out here. So this is just going to be pi over b, or 180 degrees divided by b for that asymptote. Remember, our cotangent graph is going to start up and it's going to come down and go follow the asymptote. So the y-axis is an asymptote, and so is this point. Halfway between these two would be our pi over 2b point, or 180 degrees over 2b for the middle point of where it crosses. All right, now let's do a couple examples. It will become a little clearer with the examples as we do this. The steps really are to take these, mark the asymptote. It's important to establish where your asymptotes are with these graphs, and then draw the shape, remembering that tangent starts down, ends up, cotangent starts up and ends down in their typical form. So for this one, I've got a number on the inside, so I'm going to take that 3, and I'm going to go ahead and change my period. The period here is going to equal, since I'm in degrees, I'm going to take 180 divided by 3. That's going to give me 60 degrees. And so I'm going to go, remember, half a period forward, half a period back. So that would make this asymptote here be at 30 degrees, and this asymptote back here be at negative 30 degrees. And then I start down, and then I just come into the origin and out toward the asymptote for that. Now I need to do 2 periods here, so what I want to do is take this period, I'm just going to go one full period further on, So this will be, if I take 30 and add that 60 degrees, I get to another asymptote at 90 degrees. Halfway between 30 and 90 is 60 degrees. And so my tangent graph will look like this for my second period. So I now have 2 periods graphed for this. Let's do the cotangent graph now. Notice that cotangent does not have a number inside with the x. So my period, if I'm going to do it in radians, has not been changed. My period will just be pi. The number in front, in essence, will just stretch it up. We'll make it go faster, which is difficult to measure on these graphs. But we need to acknowledge that that's what the number does, and then when we draw the graph, we probably won't see a big impact on it. So let's go ahead and go 1 period out to pi for my asymptote here. So I'm going to just draw pi here as this one. So the graph will go through the halfway point, so pi over 2. So it comes down next to this asymptote, goes through this axis, through this point, and then goes down. I've drawn it stretched out just a little bit, just to show that the 2 in front does impact it. Now I have to make a decision. Am I going to do my second period going forward with another period, which I can do, which would take me out to 2 pi for another asymptote, or am I going to go backwards? It's a choice. For this one, I'm going to go with a negative period. So I'm going to go out here to negative pi. So negative pi will be my other asymptote. Halfway between will be negative pi over 2. And then I come down from this asymptote into the middle point and then follow the other asymptote down. So for doing tangent and cotangent, we have to recognize first of all that the period is smaller than it was for cotangent and is for cosine and sine. It is only 180 degrees or pi to start with the family of functions. And then the number on the inside, you divide those numbers by that number to get the new period. With the tangent, you're going to go ahead and go forward a half a period and backwards a half period to get your asymptotes, and then start down and end up. With cotangent, you just start at the y-axis, lay out 1 full period past it, and then draw your graph starting up and going down through the middle point. If there's a number in front, it does stretch it or shrink it, but it doesn't really impact our graph the way we're drawing it because we're not being that precise. So when we look at these graphs, we can draw these using the basic steps of marking the asymptotes first, and then remembering the shape of tangent down, ending up, and cotangent starting up and ending down to get our graphs.